Hello everyone. This is my presentation for laboratory number 6. Description is numerical analysis. So, procedure number 1. The pseudo code can be found in numerical mathematics and computing 6 edition Word. Cheney, David Kincaid, page 362. So, this is the source code. So, uh, let's break down the pseudo code step by step. So, integer k, k max, and semicolon will or semicolon these lines declare the necessary variables for the algorithm. So k is the iteration counter, k max is the maximum number of iterations, and is the size of the matrix. R is the dominant eigenvalue. So real array A, L, this one, these lines declare the matrices and vectors used in the algorithm. So A, uh, A is the input matrix. X is the initial guess for the eigenvector. Y is the updated eigenvector. So external function f, this line declares an external function f that likely represents the matrix vector multiplication operation. So output 0. So for output 0, this line outputs the initial value of r, which is 0. For k equals 1 to k max 2, this is the start of the iterated loop. So for y, for this line, for y, this line computes the matrix vector multiplication y equals f close parenthesis x, which is the updated eigenvector. So for this line, x equals y slash z, this line normalizes the updated eigenvector y to obtain the new eigenvector x. So for this one, NDO, this is the end of the iterated loop. For output k and r, this line outputs the final iteration count k and the dominant eigenvalue r. So in summary, the provided pseudocode represents the power method algorithm for finding the dominant eigenvalue and eigenvector of a given matrix. The algorithm iteratively computes the matrix vector multiplication, updates the eigenvector, and converges to the dominant eigenvalue and eigenvector. So for the next procedure, demonstrate simple parameter using MATLAB. The following specifications. So let me type the source code first. This one. So where A is the square matrix and tolerance is the maximum tolerance, put all these codes on a.m script or suite of scripts that is loaded in MATLAB. So the MATLAB function should accept for user-defined function as an input argument and produce a variable containing the answer. So the provided as the user to using the key steps are, so this one let me put this on mscript first. Let me put on mscript. Newton. So let's see, it works. So it works. So where A is a wait. So the provided instructions ask the user to implement the simple power using MATLAB. So define a user-defined simple power that takes arguments x equals x, y, z, where a is the square matrix and tolerance is the maximum tolerance. So the MATLAB should accept the user-defined simple power function as an input argument and produce a variable containing the answer dominant eigenvalue or an eigenvector. So the power method is an iterative algorithm used to find the dominant eigenvalue and eigenvector of a matrix. So it works by repeatedly multiplying the matrix by a vector and normalizing the result. So converging to the eigenvector associated with the largest eigenvalue. So by following these instructions, the user can implement the simple power method in MATLAB to calculate the eigenvalue of the user-defined function simple power. So next procedure, next question. So this one to be answered into this video. So okay. Validate your answer using the Passion IG. So for the first questions, validate your answers using the function AIG constraint. Say, did you come up with the same answer? So implement the key steps would be implement the power method as described earlier to find the dominant eigenvalue and eigenvector. So use EIGA to compute all the eigenvalues and eigenvectors to the matrix A. So confer the dominant eigenvalue and eigenvector from the power method to the results from EIG. They could match up closely within the specified tolerance. So for the next question, what could probably source of errors for your algorithm to diverge? So at first, for initial guess, the algorithm is sensitive to initial guess for the eigenvector. If the initial guess is far from the true eigenvector, the algorithm may not converge. Ill-conditioned matrix. If the matrix A is ill-conditioned, meaning its eigenvalues are clustered, or the matrix is nearly singular, the power method may have difficulty converging. Numerical instability. Floating point arithmetic errors can accumulate over the iterations, leading to divergence, especially for matrices with eigenvalues of vastly different magnitudes. Reaching the maximum number of iterations. So if the algorithm are not able to converge within the specified maximum number of iterations, so it will stop and return the current result, which may not be accurate. Violence of assumptions. So the power method that the dominant eigenvalue is real and positive, and that the corresponding eigenvector has no zero components. Violation of these assumptions cause the algorithm to diverge. So for what can you conclude for this activity? At the first is importance of validation. So validating the results of the power method implementation against the built-in EIG function is crucial to ensure the correctness of the algorithm. Understanding limitations. Identifying potential sources of errors and divergence, such as ill-conditioned matrices for initial guesses, and numerical instability is important for understanding the limitations of the power method and how to address them. Implementing the power method in MATLAB and understanding it provides valuable practice experience in applying numerical analysis techniques to real-world problems. So appreciation for numerical algorithms. This activity highlights the complexity and nuances involved in implementing numerical algorithms, such as the power method, and the importance of carefully considering the underlying assumptions and potential pitfalls. That's all for today. Thank you.